welcome everyone to SQL Friday. This is SQL Friday number 50. So it's kind of a celebration or something. We only had 48 SQL Fridays, but it's still SQL Friday number 50 because 2 had to be cancelled, unfortunately. But I still keep the numbering. It would just confuse people otherwise. So number 50 and Markus Ehrenmüller-Jensen. You could say it in Danish if you like, because Markus speaks Danish as well. I met Markus on SQL Summit, or PASS Summit as it was named, last year's. He was doing a presentation about the graphs and SQL. It's Game of Hierarchies was the name of the presentation. And Markus gave out chocolate to anyone who answered correctly on his questions. That's not going to happen today, unfortunately. But maybe you can get a heart from me or something in Teams. We will get back to chocolate, I'm sure. But today it's virtual. SQL Friday will, by the way, remain virtual. I'm not going to keep babbling. So welcome to SQL Friday, Markus.
Thank you.
Pleasure to have you here. The stage is all yours.
Thank you very much. My name is Markus Ehrenmüller-Jensen. So Magnus pronounced my name much better than I can ever pronounce his. So this is 1-2-0 for him. I will start sharing my screen.
Oh, and everyone knows already, but if you have questions, type them in the chat and I will find a good time to interrupt Markus.
Yes, or unmute yourself if the system allows you to. Just talk to me.
Yeah.
Very good. So we can just have as interactive as possible. At least if you're not watching this as a recording on YouTube, this is then not a YouTube video, this is live. So please come up with questions. That's the best way to learn things. I mean, you can also relax.
That's the thing for those of you who watch this on YouTube. You're missing out so much fun, So next time, come to the live event.
Yeah.
I'm going to keep quiet now.
Okay. Okay, so this talk is about from SQL to R, because this is my story. I'm fluent in SQL, and then I found out that Microsoft bought this company, Revolution R, which is behind the commercial version of R. R still open source, and then they incorporated it. And also this data scientist thing with machine learning and so this attracted me really, because this is always the problem we're having. We want to predict into the future. We find clustering. We want to apply things. And R is really easy to use here. And so I know SQL, but I didn't know R. This is my story. And then I struggled. I feel like amputated because I could do things in SQL I could not do in R when I began with R. And this is the idea behind this talk. So we start with really easy syntax. How can I do things I know already in SQL? How can I apply this to R? And at the very end, so even if this is an introduction thing, we start at the very, very beginning. At the end, we will write a script where we do time series predictions. So we take from AdventureWorks, we take the sales amount, and we do then a prediction into the future, and we show this in a graph within R. So this is a lot of content, so to say. So there's only a few slides which I'm using, and I will most probably only talk with the demo. So this is an introduction to R and also the motivation behind it. R is well integrated into the Microsoft Data Platform, and depending on how fast and how much I talk, there will be more or less time then to show you actually how this is integrated to the Microsoft Data Platform. For example, in Power BI, for example, you can run an R script on SQL Server. So what is R? R is a programming language, sort of, if you compare it to Python. So Python would be the other language which is really famous for machine learning and stuff like that. I would say Python is more a programming language. R is more a script. We're doing a lot of just calling to functions, getting something back, manipulating this, and then taking this as a parameter for the next function. So this is more like DAX, if you ever heard about DAX in Power BI. This is also a function language. It's strong typed, but dynamically typed. You will see this in the first demo, that this really makes sense to write like that. And it's interpreted. So there's no compiler involved. You just run the script and execute it. It's open source. and the community out there is really, really active. So if you think I'm a proud member of the SQL and Power BI and Power Platform community. I think this is really awesome what Microsoft built here and the community built here, but R is even more active. They're doing even more things, which is almost unbelievable as the SQL and Power Platform community is already very active. And the nice thing with R is it can be extended with packages. So you have libraries or packages, and most of the packages are published to CRAN, the comprehensive R archive network. And this one command, load package, install packages, and then you just use this library. And I looked up yesterday on the evening, it's over 17,000, over 17,000 packages out there. Every package having at least one function, so one machine learning algorithm, for example, maybe several of them, and also demo data. So this is really overwhelming if you start learning R and with which package to start. So this is also the idea of this talk. I give you an idea of a handful of packages where you can start. And if you hit the limits of these packages, then you would try to find a different package to make this possible what you wanted to do. So one category of the packages is about statistics. So R is the successor of a language called S. S is still out there. S for statistics, I assume. And S is a commercial product, and they forked it, and R continued as an open source version. So you can do your metrics calculation if you want. I can't remember how this is done. This is a long time ago in school. I had to do this. Or, for example, descriptive statistics, calculating averages and all sorts of those things. There's also packages available for machine learning. So if you want to do a linear regression, a clustering, neural network, whatever, R is also very broadly used on universities, so for the academics. So there's a huge chance if there's a new algorithm available, a machine learning available, that there's also a package out on R which then you and me can use, even if we don't understand the in-depth logic behind it, and I can't prove that this algorithm makes sense or makes not sense, but I can apply it, I can use it with just installing the package and then use it for free. And of course, data visualization. It's also very important that when we work with data, I think also people in R discovered this soon, that you have to get a picture about the data. So there's a lot of packages out there for plotting the things. And we will learn one of those plots packages here. So SQL and R have a lot of people things in common, not people, things in common. It's used by data people. If you work with data, it makes sense that you know SQL. It also makes sense that you know a little bit at least about R. So you have to extract data, we have to load data, we have to transform data, we have to analyze it. So the task is always the same if you work with data. So, and they can be used then or done with R and SQL as well. Both are interpreted, both are available for Microsoft's data platform as they integrated this. So there's still this R Revolution R. This is now called Microsoft R Server. There's a commercial software available. The open source version of R is still kept. So there was a little bit of panic in the community when Microsoft buys an open source tool. Will this available? Will this stay available? Yes, it did. And also the competitors like Oracle or Teradata included R into their platform. Also, this is still working. So Microsoft did not take this away. And this leads me to the demo. So we will now use almost the rest of the time in demos, and let's see how far we're coming with that. And here is my demo environment. If you can't read that, please let me know, then I can use Zoom for it. So can everybody read this text here? Or who cannot read the text? Then let me know.
I think it's okay for me at least. Okay. Let's see. We have some answers in the chat. Yes, no, okay for me. Please
Zoom in. Okay. Maybe I can also set this up newly, so I forget where I can I increase the font size here, the code, display saving. I set up a new here we go. Yes, appearance. This is what we need. So make this maybe 18. Apply. Oh, okay. I need to restart. Save selected. Then let's restart. And yeah, better.
That looks awesome.
Yeah, very good. And that's the usual font size. I use always 18. And when people see me working on my computer, they will think I'm blind because I have huge fonts. And the only reason is because for the trainings and web talks, it makes sense to have a huge font so everybody can read everything in a very relaxed manner. So what we're having here is RStudio. So RStudio is not part of R. This is two different things, but it's also open source. So you can install, you have to install R first and then install RStudio. And then, or you could also use, I think it was an extension for Visual Code, but I'm not sure if they're still maintaining that because everybody stayed with using RStudio. This is widespread use. This is the standard IDE for that. And then I've on the left upper corner, I have a script. So I have scripts prepared, so I don't have to type everything. And you see me doing typos, so I just will execute the scripts. If I execute anything, it will be executed on the console. So I could also execute something here. For example, 1 + 1, and I have the wrong. Here we go, US. That's not very helpful. German is much easier for me. So 1 + 1, if I type this in, I get the result 2. So I can also type in things, but most probably you will come up with a script in here. Then as soon as we start running things and creating objects, they will show up in the environment up there, and different other things like files, packages, and so on are listed on the right corner, and you can change this, but usually people stick with the standard thing because this is what everybody uses. And it makes sense to have it like that. So the most important part is how can we execute things. So if I want to execute something from here on the console, I just put my mouse cursor in there and hold the Control key and press Enter. This is what I really like, and I miss in SQL Management Studio. If I work a lot in R or other languages and I come back to Management Studio, I always try to press Control F, Control Enter to execute the current statement, and this does not work. I'm not sure why they're not building this in. You always have to mark everything and press F5. This is easier here. The most important thing is comments. So we only have single line comments because comments are so important because you want to comment and document your code. If the comment doesn't make any sense, then most probably we will change the comment, but not so much likely also change all the documentation out there. So I think the only documentation which is the correct one is the inline comments in here. And we only have single line comments. So that means the rest of the line, if you have this hash, this pound symbol or hashtag or whatever you will call it, number symbol, then the rest of the line is then a comment. Then we can do different calculations by having expressions. And now we see this is open source, and open source in this case means there is not so much standards. So we can have strings with double quotes. We can also have strings with single quotes. Totally up to you what you want to use. It's good if you're coming from one of the other approaches, but it could be confusing if you mix the things up. So most probably you should stay with one. Either always use double quotes, always use single quotes, otherwise it's confusing. Then of course we can execute things. I already demonstrated how we can add things, multiply things. We can calculate 2 to the power of 16, which is 65,536. As easy as that. So you can calculate with R. The next thing is that we can have objects. So for example, I can have a variable a, where I assign with the equal sign a string in here. So if I execute this one, I get in, I see that it's executed. It's not displayed, the content is not displayed, but I get now in my environment, I get a new variable, a variable a with the content of SQL to R. Again, this is open source, so there's not only one single way of assigning values to a variable, there's several ways. We can also use this symbol. So this is not a greater minus, this is an arrow pointing to the left. So it's called a left assignment. So I take the thing on the right and assign it to the thing on the left. So that's what we also can do it. Will not change the content, it will just do this very same. As there's a left assignment, there's also a right assignment. Can also do it the other way around. It's very rarely that I see this. So the most common one is this one for some reason. So left assignment is if you look up scripts on the internet or in books, mostly the left assignment will be used, not the equal sign. We can also do the right assignment. So we assign something to the right, and there's also an assigned function on top of that. And this assigned function is special in the case that when I pass in the name of my variable, I have to pass it in a string. And I think this is a little bit confusing because I would not use a string, but I would just name the variable. So again, if I execute this, always the same. If I only have the variable name, then the expression will be evaluated. I see the content like up there. I see it also down there. Or if I have some statement which is doing something, I can put it in parentheses, and that means that the assignment is done and also the result will be shown. So instead of having 2 lines, assignment and show the content, you can also execute it in the parentheses, and then it will assign it and it will also show the result SQL to R. So
we have a question, Markus.
Yeah, of course.
How do you run a selection of lines and not just one line?
If I have more lines, I can just mark the lines and then I run them. So up there, run the current line or selection. So I could either click this button or I could also press Ctrl Enter and everything is now run. So if I clear this up again, maybe to make you aware. So I mark this thing here and then execute this, then several items were executed.
Awesome, thanks.
So this is similar to Management Studio. You mark things, press F5, here you do Ctrl Enter. Yeah, same as T-SQL in yes. So the assign function is then special. And this is also typical for R, I would say, that some things are, there's lack of standards. Yeah. You know, I'm Austrian and Austria is close to Germany and Germany is proud of the standards. And maybe I also have this some of those in my genes. And I really miss standards. So this is sometimes confusing. Also, I think for every beginner, not probably only for me. So if I execute this one upstairs, was the wrong one, wrong key on the keyboard. So if I execute assign and put a not under quotes, but as the variable name, and I assign another content and I execute this one, then you will see that suddenly I have a new object here, SQL to R. Why is that? Because the assign function looks in the content of the variable. The content of the variable a is currently SQL to R. And if I then assign, then it will create an object or assign to an object called SQL to R, this another content. This can be nice of having like creating dynamical objects. You could have a loop or something like that and creating then variables with the assign function. But for the typical assignment, I think this is confusing. We can also list the objects. So ls lists all the objects a and SQL to R. And this number 1 means this is one line or the first. It's not one line. The first object is number 1. If this is going over several lines, you will see more numbers. We'll see this also later. And then I told you that it is dynamically typed. So in R, I can have my variable a and assign 1 to it. So if I do that, then previously it was a string. Now it's a number. And then next, I could take the same variable and assign, in this case, this is an array. So C, the function C, so this is the function C with 2 parameters in parentheses. The function C combines values. So we get an array of values. And this is, you will often see this in the scripts. So if you pass in a list of values to a function, for example, most probably we will use C to make an array of those values. So we can then change, then assign the result of this array, combining 2 values, 2 numbers to one array. So A is suddenly an array. Not this changed it. This is a numerical array. It has 1 up to 2 parameters. So this dot is like in Excel. If in Excel have an area of cells, you also use the column here, and the first 3 values will be shown. So 1, 2. If it's more than 3, then we see the dot, dot, dot there. You don't see this. So this is dynamical. I can on the fly change the type of my variable. I would really not do this in many of my scripts because I think this is confusing. So this is possible, but probably you should not do this too much. But it's strong type. So if I have one variable with a and another variable b with a string, and then I try to add a plus b, that's what the strong type come in, I get an error message. I cannot calculate a number of 1 and add a string of x, y, z. So this leads to an error, but afterwards I can change the content of the variable and the type of the variable again to a number, and then I can add up a and b, which results to 3. Okay, then another thing which drives me crazy is case sensitivity. R is case sensitive, and we cannot turn it off. And I always struggle when the databases I have to work with are case sensitive. I get the idea that maybe it's a good idea to have to force camel case names, for example, in functions or tables or columns. I get this idea. But on the other hand, case sensitivity on the database means that I could have 2 tables with the same name, but different case. and there would be two different things. And how would I refer in any discussion which one of those two tables I need? So that's why I don't like case-sensitive tables, but case sensitivity in the databases. But I totally get the idea, and there's no time to discuss this right now. Maybe you have different feelings about that, and hopefully I didn't hurt your feelings. If you like case sensitivity, I don't like it that much, and I can demonstrate again here. So I have one variable a, SQL to R, and another one a, but in capital. Then I have two different objects now here. So I have a in small capitals with SQL to R in capitals, and capital A, yeah, in a different writing, different case. And this is two different objects, and I can even compare them. So if I use the double equal sign, this means compare the content of one thing with the other one, and the result is then true or false. And it will tell me false. So the result of this condition is false because the content is different. Also, the comparison, the content is compared case sensitive. Okay, any questions so far about the syntax here?
Nothing so far. Nope.
Okay, then we have a lot of other functions. So for example, everything is a function. So you can even have the Q function. This quits the session. So this will close RStudio. So everything is a function. Even closing RStudio can be done within function. There's the help function, which is really cool. And this is tied to if you're using packages only from CRAN, Comprehensive R Archive Network. They have, if you check in something as a package there, they have to fulfill something, some conditions, and one condition is there has to be documentation available. So if you're using only packages from CRAN, there's always also documentation downloaded, and we can use this offline. So you get an idea of what this function is about, or you could pass in like help C. C is this combined function, and then I can ask for what the combined function does, description, how is it used, assignments, details, values. This is really, really good. It's easy to learn. The only thing is you will be overwhelmed by what's possible. But if you found out that you might want some of those things, there's good documentation, there's good forums out there. So from that perspective, it's easy to learn. Yeah, a lot of other functions. And there's also descriptive statistics. So if it calculates the mean of values, remember C function creates an array. So we got now a list, so to say, or in SQL we say a temporal table with 4 values, 1, 2, 3, 5, with 1 column. The mean of that would be, I don't know, 2.75. The median, which is the better average, maybe you know the difference between the median and the mean, has the problem. So it's summing up all the values and then dividing it by the amount or by the number of values. So summing up 1, 2, 3, 5 and dividing it by 4, and the result is 2.75. The issue is if I take in now 100, that the mean will be 22. Yeah, which is because there's an outlier. The median is not reacting to this thing because the median will then take all the numbers, sort them, and find the middle one. If there's an even number, then it will take the 2 middle ones and make a mean out of that. So it will show 2.5. If I add an outlier as well here, it will only increase to 3 because now I have 5 values and the middle one will be 3. So the median is most probably the better average, I would say, for many use cases because it's independent from outliers. And then we can also calculate the standard deviation. So there's a lot of functions out there. I'm not a statistician. My background is in development and databases, but you will find plenty of things there. So if your children struggle with mathematics in school, most probably we found solutions in R to help them to calculate things and to check if they did the examples right. So next thing is data types, and I will speed up a little bit. So there's a lot of data types out there. With the mode function, you can find out what is the type of this. So for example, number of 1, the mode would be then a numeric, or there would be even the complex type. So you can even calculate with complex numbers. You can remember I is like the square root of -1. So usually the square root of -1 cannot be calculated because the square root is the other way around of the potential to 2. And if you multiply a number with itself, it always has to be positive. Complex numbers, yeah, I can only remember it's the square root of -1, and I can't remember what the use cases were. They're out there, but not for my customers. I usually do business problems, and we do not struggle with imagine numbers. What's the number? Imaginary. Imaginary. Thank you very much, helping out there. So the complex data type, imaginary data types. Then we have also like to check if something is infinite. So for example, if in SQL, if you divide 3 by 0, you get a null. Null is unknown or not defined or something. This is like a placeholder for many different things. R is much more special. So if I divide 3 divided by 0, this is not an error. This is just infinite. So 0 can fit in 3 an infinite amount of times. There's also then minus infinite. So if I have a minus 3 divided by 0, I get minus infinite. There is also then not a number. So if I divide 0 by 0, this is a different use case in mathematics. This is not a number, and then I can check if something is not a number. Fun enough, if I subtract infinity from infinity, then it's also not a number. And then we have also NA for not available. For example, if I check if not a number equals not a number, this is just not available. So there's different, what only would be null in SQL. There's different results here in R, so you can much more precisely react to it. This is more precise in a mathematic manner. And we'll speed this up. And there's also null available. So if you load things from the database and it contains null values, which you can't say because null is not the value, so null value doesn't make sense, but I think you get what I mean. If there's null in there, this is also represented as a null then in R. And we can also get metadata. So for example, that this is this would be an array, and if I do this, then I see from the class, this is still numeric, but if I do a matrix, for example, then mode of the class would be different. It will tell me that it's a matrix, and the class is an array, and str means structure. So get a sort of a content, what's containing here. So now I executed this one for the matrix. So this is a matrix having 3 lines, 1 column, and the first 3 elements is 1, 2, 3. Then there's also a list object. So a list object is like a record. There's no record available in SQL or T-SQL, but in other languages where you could then have like you have the name, and then you have an address type, and the address is a record having the street number and the zip code and the country and so on. And there's like a home address and there's a business address. This would be then records, and the list object would be able to do that. So we would have a list object of the first name and the last name, and then again of another list which contains the street name and the zip code and so on, and then another list again with the same thing. So this is sort of a list. You most probably will not use that. What we really will use that, and that's the important part, is the data frame. So what you know about tables in SQL, you can just expect the same from a data frame. For some reason, it's not a table. I think there's also a table data type in R, but typical for a table in SQL is you have columns, you have rows, you have a name for a column, and every single row in this column has to obey the same data type. And this is exactly the same for data frame. A data frame has columns, has rows. Every column has a name, and every single row in this column has to obey the same data type. So this is a similar concept. If you know tables in SQL, you know data frames. So this is a shortcut for you. And that's what we will work with. If you load data into R from a CSV spreadsheet or from a table, SQL table, you will load it into a data frame. Sometimes it's also called data set, but the real name is data frame. And what we also can see here, a dot is not a special character in R. So this confused me also. Now I'm used to it, so I forget about explaining it. So this is the name of a function, data.frame. This is a valid name. The dot has no special meaning. In SQL, it's not possible because in SQL we have the database name dot, table name dot, schema dot, column, table name, table and dot column, for example. Of course, you can omit some of those. So the dot has a special character. In R, it's not the case. You can use it for variables, for functions, everywhere. And it's used heavily because it's a good idea. Instead of having the camel case, like data frame, in SQL I would write data with capital D and capital F. Here we have data.frame to make the two words separate from each other. So data frames. I think this is the more exciting thing for SQL people. So what I first create is I create 3 vectors, which I call col1, col2, col3. Because they will later become my columns in my data frame, the first, the second, and the third column. And again, we have this good old friend C. I'm combining C for combining 4 values, 4 integers into one data frame. So this call1 will then be not a data frame, but a vector. Did I say array? I think vector is the right thing. So this comment is right here. This is vectors. Now I got 3 vectors, and then with the data.frame, I can combine those 3 vectors into a data frame. So a vector, a matrix, and a data frame, different things. You want to work with data frames. So I can then create left assignment. Again, this is not the equal, could also write the equal sign, but here I use the left assignment here. So I create a data frame, which is called df, which is commonly used throughout many scripts, very uncreative, I would say, df for data frame. And then if I show this, then you see exactly this looks like a table in SQL. We have 4 lines. Even Management Studio will show you the line number. RStudio is also nice to show us the line numbers. Then we have the different names, call1, call2, call3, and I see the different values. So the first column, 11, 21, 23, 31, 41. This is exactly the values we're seeing here. And then we can access. So now we can access those through different syntaxes. Again, there's no standard, so we have plenty of possibilities. One is to use the brackets, and then we pass in first the line number, and then second the row number. So the third line, second row. So this would be 32, what I would expect from here. And this is exactly what I get here. So we can access it through the brackets. I can omit parts of it. So if I pass in only the line numbers, but no column name, then it means that I get the whole third line. So I get the values 31, 32, 33. Let's see if I'm right. Exactly. So I see the whole third line and all the columns. On the other hand, I could omit the line number and only pass in the number, for example, the number of the column. So I would then see, what is it then? 12, 32, 32, 32. For some reason, it's showing us horizontally, not vertically, but still this is the content of the column. 12, 22, you can see here, 12, 22, 32, 42. So the UI is a little bit confusing here. This is still a column, but it's shown row by row. Another way of accessing this would be the $sign. So in SQL, we're using the dot to write table name dot column name. In R, we're writing data frame dollar column name. So with $call2, I get exactly the same result. Or I could just write 2 without any commas. That would also mean please show me the second column. And this time it's formatting at the column. So maybe this is the preferred way then, because then it looks like a column in a table. I could also attach the data frame and then just use call2 as the column, as the variable. This is also possible. Or, and the detach again, or with the width, I could say only for the sake of this expression, if you can't find the variable, please look up the data frame if you find the variable there, and then use the variable from this data frame. So this results in the same thing. Then we can manipulate the data frame. So any questions here? Talking a lot. So column 4, again, another column, and then with the cbind. Cbind means column bind. I can bind to an existing data frame. I can bind another column. Cbind for column bind. So with this, we get, no, I have to first, of course, to create the column, the variable, and then we get a fourth column, 99, 98, 97, 96, as the fourth column with 4 rows for this data frame. And you might guess it as cbind adds another column, rbind adds another row. And in this case, I didn't create a variable for that, but I just pass in the C function directly here. So we can also cascade functions. So we can have the result of a function as a parameter for another function. That's what I'm doing here. So if we take a look there, then we got a 5th row with those values here. Then the funny part is, how can I get rid of something? So the cbind, rbind, there's no delete line or delete column, but I can request a data frame. Remember the bracket syntax, where when I pass in 5, that would only show the 5th row. If I pass in negative numbers, -5, so if I only execute this portion, not doing the assignment, I see everything except for the 5th row. And this is how I can get rid of the 5th row again. So if I get the result and assign it back to the data frame, I got rid of my 5th row. Okay, so this is also possible to have negative indicators in our rows and line numbers, and that means show everything except for those numbers. And if it's more than one column, then we could pass in again our good friend C for coming up with an vector and then passing in 5 and 6 and a minus in front of it. It would be then delete the 5th and the 6th row from my data frame. Okay. In many cases, you will not create a data frame like that because usually you have to work with existing data and then you have to load the data. So one way would be to load data from a CSV file. And that's what many people working are doing. So if they're working in R and you are the database owner or admin or somebody who can query the database, they will ask you, can you please give me this as a CSV file? Because there's plenty of functionalities in R to work with CSV files, as we can see here. So I can, with set WD, I set the working directory to my path locally on my computer in here. And then I can call the function. This is part of the base package, so you don't need anything to install. Read.csv, and then I pass in the name of the file. So in this path up there, there's this factory visualization by date subcat.csv file. That's what I'm reading and loading into my data frame. So now a data frame is created. So you can see data ADF. This was existing data frames, and now we create a new one, factory sales by date subcategory. So I use the same name like the file name. So it's easy for me to remember what's the content of that. And that's how we can load things and then work with this data frame. Another way would be to give those people directly access to the database. So we don't have to export it first and then load it again, but directly connect there. Has advantages, disadvantages. And there's a package. So with install.packages, if you have a brand new installation of R, then this package is not available. So you have to call install.packages and then pass in the name of the package in double quotes. This will reach out to CRAN, the Comprehensive R Archive Network, and download a zip file and then extract it and install it on your computer. Depending on the size of the package, a couple of seconds or a minute or so. And then I can use this package. So I load now the library with library RODBC. And from this point on, now the base package, the base functionality is extended, and I can also use functions from this package. And one of those package functions is the ODBC connect. So RODBC, I think this is self-explaining. This is connecting. This enables me in R to connect to an ODBC driver. So I created with my local Windows settings an ODBC connection called local server. And then I have to pass in my user ID, which is read only, and a password, which I can show you here, password. Yes, it's an indeed password. It's not a secure password, of course, but this is locally on my computer. And if you get access to my local computer, then I'm in troubles anyway. So the password is then the least problem I'm having. So I create a connection then, and this connection I can then use again from the RODBC package. There are functions available, SQL query. Remember, this is case sensitive. You have to write it exactly like that, SQL and then capital key, query, passing in the connection, and then I can pass in everything this connection understands. In this case, it's a SQL server, so I can pass in SQL in a T-SQL syntax. So everything the server understands, I can pass in here. So I can then load, for example, the product category table or the subcategory table, or again, the factory sales by having a query in there. And for example, for this one, this is a more complicated query. I'm not using select star, but I'm using the projection and only asking for order date and sum of sales amount and renaming it to sales amount, and then have a group by at the very end on the order date. I just execute this one, and then this is loaded. Okay. And then when I think loaded, I usually look into is this the right thing? So what we can do in R is I can click on the data frame here. So this is a funny functionality. If I click there, then it should open up another. Did it? I think this. Can I double click there? There was something where I can have a look into that. Did something change on this installation? So there's a way of showing this like an Excel sheet. This is one way. But if the data is big, then you not want to load everything into RStudio. So what we can do is in SQL, I would write select top 1, top 10, top 100 to see the first rows to get an expression if this makes sense, what I just loaded there. In R, we have a function called head. If I only pass one parameter into it, then it will show the first 6 lines. Don't ask me why it's 6 lines. It could have been 10 or whatever. The author chose 6 lines, and we can see the line numbers in here. And now, as the screen resolution does not allow to show everything side by side, it's now opening up another line. So this is still the 6th line, but this is English product subcategory name and the sales amount subcategory. And up there, I see other columns: standard cost, total product cost, discount amount, also the 6 lines, and so on and so forth. So this is split up now to many lines because of the font size. If I pass in per parameter, that means I only want to see the first line. And as there's a head, there's also a tail. I can ask for the last row. And then R is smart enough, or RStudio is smart enough to actually show me this is the 441st line. Management Studio would still show 1 because the first line of the query. RStudio is read as a data frame, and every line has also a name or a line number attached to it. And this is what will be shown here. The other thing is then the projection. So if I only want to have several columns, not all columns, I can use the brackets again. And firstly, we used numbers. So the index number of the column of the row. I can also pass in names. And if it's more than one name, our good old friend C combine will create an array of names. And I have to pass in this under quotes. So order date, English product name, and also the sales amount. And that's it. And if I ask for that, I get the full list, all the lines, but only the 3 columns I asked for. So if I scroll up there a little bit, come on. So then we see the order date, English product subcategory name, and sales amount, exactly the columns I asked for. This is the standard package. There's also the dplyr package, which is a cool package. And they have this syntax like, this reminds me of Unix, where you have this pipe symbol. Unix, or also in DOS, you can, or in PowerShell, you run something, and then the outcome of this is then the input for the next command, or whatever you would say that. And dplyr is working in the same way. So I have the full data frame, and the greater symbol is already reserved for a comparison. So we have to mark this with these percentages. That's how the syntax is. And this means that I take the whole data frame and pass it over to the next function, and select is a function from the dplyr package. And then I can name the columns I want to see here. And this is really useful because this reminds me of SQL. Select and then pass in the columns. So I get the same outcome here. I couldn't find function. I did not execute the dplyr. Only pointed out, marked it. Now we get the same output here with the dplyr. Then the order by. Either we pass in, where is it here? We can pass in the order function on the line numbers. So again, the brackets, it's the bracket syntax, and the first parameter is about the lines. And if we pass in the order function with some name, then will be ordered by sales amount. And then I only want to see certain columns. This is one way of doing it with the standard way. So we have the biggest sales amounts below on bottom, and then the more you scroll up, the lower the numbers get. And the same is possible with the dplyr package, but here it's a range. It's not order or order by. Unfortunately, it's a range. A little bit confusing for me to remember. They can also order. Then we can filter. In SQL, we would write a where clause. In R, I can pass in again in the bracket syntax. I can pass in a condition. So I only want the subcategory name to be equal to, for example, my road bikes. If I execute this, then we only get road bikes. With the dplyr, it will, there's another, the in function. If I have several, so I want the road bikes or mountain bikes, I want to see both of them, then we can have the in operator, also very similar to what we have in SQL, in. And then in parentheses, we pass in the values. Here we have to use the combine function. That's the difference in here. Same result, and then we see the road bikes and the mountain bikes. With the dplyr, there is a function called also not where, but filter. So that did not really react to what's already available in SQL. So it's different names: select for selecting the columns, arrange for ordering it, and then filter to apply some conditions here. Then with unique, we get the distinct values. This is also sometimes useful. And then we can aggregate. So we can sum up things. And to make this first easier, I built a new data frame from scratch where I have a column A with those values 1, 1, 2, 3, 3, and a column B with 2, 3, 3, 5, 6. And if I create this data frame, so we see those values here, A, And then I want to group by A. This is the same function we have in SQL. You can group by one column. Group by A means that A only shows now 1, 2, and 3. So get distinct values of A. And summarize means I want to apply a certain function to aggregate the things. And what do I want to apply? I want to apply the sum function on the column B. And afterwards, it's still called B. So this is the alias. This is the column from my data frame. Sum is the function I want to apply. And summarize is a function which allows me to apply aggregate functions. Again, this is the dplyr package I'm using here. So when this is right, I would see 1, and then for B, we would get 5, 2 plus 3, 2 and 3, and then 3 and 5 plus 6 is 11. That's what I would expect here. And exactly that's what we're getting, 5, 3, and 11 for the B column. Of course, we can also apply this to our data frame from AdventureWorks. So I can group by the category names. So now we get 1 row per category. This is bikes, accessories, clothing, and components. And then we summarize. So one way is to summarize the sales amount. So we get the sales amount per category. And there's another syntax, which is also interesting. I can also have another sales amount total, this time count, and sum. And then I pass in not only the column name of the data frame, but I pass in the data frame name, the $, and the column name. And this leads to that this is now the scope is like, this is like the overclause in SQL. We get done not the individual sales amount, but the full sales amount, the total sales amount for the whole query. This for itself is not so helpful, but of course I can then calculate the percentage where I take the sum of sales amount divided by the sum of the data frame name sales amount. So then we get a percentage how much of the sales are then used for a different were achieved by different category. So accessories having, what is this for a number? 1.3 million. A total we have 25. This would be 0.5%. And then we have 16, or this is 100. This is 160 million. Over 160 million. This is more than half of the 245 million we're having here. Yeah, and then you can also add columns, like calculate the columns and so on with the mutate. With mutate, I'm not really changing the data frame, only the results. I'm passing in the whole data frame, and then with mutate, I add a new column margin, which is the difference between sales amount and total cost. So can do here. So in the very end, so this column at the very end is then the margin, which is not part of the original data frame, but just part of the result we're getting here. And if I want to add this column, for example, I could write factory associates. I could just add this way. Having the wrong keyboard again. So like that. This is how I would add then this column to my data frame. Then we can do joins. So combining data frames. Remember, data frames are sort of tables. Then I create again one artificial one with 1, 1, 2, 3, 3 as a customer ID and then different sales amounts, and another one where I have a customer ID and then I have different names, X, Y, Z. Not very important. The important part is here that we have a sales amount for customer 3, which is not available in the other one, so we don't have a name, and we have a name for a customer 4, which does not have any sales. So we can now try out full outer joins and left joins and so on. That's what we're going to do in the next couple of minutes. And I'm running out of time. There's so much I want to tell you. So I only want to show the first one. So with the merge, I can then say, please join the customer ID, and I want to see all. That would be a full outer join. So that means that I get everything. I get the 4 without any name, without any sales amount, and I get the 3s where we don't have a name. And then you can combine those things. So I will speed up a little bit because I want also to do the prediction with you. So I think the basic is now set, that we understand the script. So what I'm doing here. Any questions so far? Okay. I'm using the Profit package. And Profit is like looking into the future. And this is exactly what this package does. This package is maintained, came up by Facebook. So I'm not sure if you like Facebook or not, but this package is really, really cool, allowing you for doing time series. The screen froze. Not sure if anybody else is having the same issue. Please tell me if the screen is froze. You should see my mouse moving. If it's not,
I see your mouse moving. Yes.
Okay. So maybe Sarita, leave and join again. This would be one option, or I could leave and join again if several people have the same problem. Okay for me. Okay.
It's to be okay for Grant and it's okay for me. So I think, unfortunately, Sarita,
Yeah.
it's on your end.
So library, I already installed this, and this package allows me to doing time series predictions. So I load this package, and then I create a new new data frame out of my factory seller sales for prediction data frame. I only choose the order date and the sales amount. So now we are applying those things I tried to explain in the previous 40 minutes or so. And then if we, this is also really funny. I like this. So if I use the call names function and apply it upon my data frame, I get the names. Also, I did not execute it. So I have to say for prediction is not found because I did not run a very important script. Sorry. This is this one. So I need this one. I need to execute this one. Takes 2 seconds to execute. Then we're going back to my prediction. Yes, and then it should be available. Now it's working. Yes. The call names is then showing me the column names, so order date and sales amount. And Profit is very strict here. We need one column called DS, which calls the date parameter, and the other one has to be Y, which calls the value, the current value, which will then be predict. So the profit package will be then take the dates and the Y and analyze the data, come up with a machine learning model, and then give me predictions for the Y value, which would be the Y hat. So the Y with the hat, the little roof on it, that's the Y hat value, this is what's coming up with. And it has to be, we cannot discuss this. And call names, and this is the funny thing, call names returns me the column names, and it can assign something on the result of a function result. And this was new to me. I never have seen this before. So obviously the return value of a function is by reference, not by value. So I can assign something on it. So I can rename the data frame by assigning something on the return value of columns and passing in again a list, an array of new names. So
It's a combination of powerful and confusing on speed.
Yeah. It's like at the border, yeah. If you see it first, it's really confusing. Then I was really impressed, and yeah, now I'm changing my minds constantly. So this is how we can rename the column names. Then I rework the DS. Remember, that's the order date. I make it a Unix timestamp because that's what the profit package expects. And then I overwrite. So I use the format function here. I overwrite the day in my data frame. So my data frame, AdventureWorks sometimes has sales on the 2nd and sometimes on the 12th of the month, but not really daily data. So we cannot do daily predictions with this sort of data. So I just overwrite the day with 1. So everything moves to the first of the date. And then I aggregate this with the profit package, and then I can do a monthly prediction. So I do not want to confuse the profit package with dates or sales spread among the several dates in the month. So execute this one. And then I group by things, by date. So I only have 1 row per day with the sum of the Y value, which is my sales amount. That's what I'm doing here. So now my package is prepared. And then I use the profit function and passing in my data frame. And this is returning a model. So if I do this, yeah, I think I haven't had a similar issue here. Library. I had a similar issue yesterday. Then I solved it by reinstalling the profit, the dplyr package. Let me find if this does the trick. Install packages. Yeah. Restarting. And then afterwards, it solved my issue yesterday in the evening. And I thought I solved it constantly. Let's find if this is running. Is not found. So again, except this one. Not so much time left. This is really bad. Let's see. Yes, now it's working. I don't know why I have constantly installed the package newly. So this now comes back with a model. So this is a machine learning model we created. Again, profit does time series, so it's analyzing the trends, it's analyzing the seasonality. It's very powerful. We could pass in like holidays. So for Facebook, it's very interesting. Was a certain weekday a holiday? Because on holidays, people tend to be more active, and then it makes sense to also see this in the predictions. If I know a certain date in the future is also a holiday, then this model react to that. And then I build an empty future data frame. So make future data frame, pass in my model, and ask for 6 periods, which are months. So this is what this is doing. And then I predict. So I pass in my model, pass in my empty future data frame, and predict. And then what I'm doing is I merge everything back. So I now have then everything in one data frame, the current value and the predicted value, and then I can plot them. That's what we will do next. So future, this is what I did. So if I then view the last 8 numbers, then we see the 7th last one has an actual value. Y there's something in it, and Y hat Y is the predicted value. So now we can also compare and see how good is the prediction by comparing the actual value with the predicted value. So this can be also applied to the not only to the future but also to the current ones. And as I ask for a data frame for 6 months, I get 6 additional rows in here with no current value because we don't know what we will have sales amounts there, but with the predicted values. And that's what I then use for the ggplot package. So ggplot and scales helps me to plot things here. And ggplot, grammar of graphics. I pass in my forecast, what you just have seen. I'm asking as aesthetics, I want to have the dates on the X values, the Y value on the Y axis. The color should be 1. I want to see this as line and as points, as dots, so I see where things changed. Please make it a big size graphic so we can read everything. I stick the y-axis to values between 0 and 5, not dynamically. And then I pass in, I ask for another line, but this time not the actual values, but the y hat y values from my data frame in a different color. No legend, and then I put in labels for order date and sales amount, so this makes sense for me. This is what I'm executing here. And then we see now with our own eyes, I can also zoom here, so we get this for a full screen. So now the blue line and the blue dots are the actual, the blue dots are the actual values. They're ending somewhere in 2013. And the red line is the prediction going up to the future. So now we build within 1 hour. As first we did the prediction and a plot here. And by applying this also to the back, you can then evaluate if this is good enough or not. And what you can see here, the seasonality, so this like is an M-shaped pattern. The same M-shaped pattern is also 12 months previously, and then again 12 months previous. The numbers, the M is on a higher level than this one because this model discovered an upwards trend in my data. And sometimes the prediction is really, really close. Sometimes we are really, really off. And this is because this model finds a trend and the seasonality. And if something sometimes in the past was outside of this predicted or recognized trend and seasonality, then we're off. And then we can try to tune the model and make this prediction even better. So this leads me to an end. Before I run out of time and come over time. So are there any questions?
There are no questions that I can see, no.
So R is included in some of the things, so I can just maybe I show you just take 10 seconds more out of my time, of my not existing time. Just decide on that. So what you can do is just to show you, you can run this in, again, this is a really small, I zoom in here. No, let's do it like that. Okay, Zoom is not working here because I have to be outside, or what is it? Yeah, no, not working. So this is Management Studio, and there is this SP external script procedure available since 2016. And in 16 we only had R as a language. In 17 we got Python, and since 19 we also have Java. So hell is freezing now. The language is Java, and they can pass in a script. This is a really silly script. It's just taking the input data set and assigning it to the output data set. What is the content of the input data set? I have to pass in a SQL query here. So I have a query here, the order dates, the same numbers again from my factory sales, I pass in, and then the output I have to describe here. So I get returned an order date and sales amount. Of course, this script does not make any sense to take a query and just take it through R and then don't manipulate it, but you get the idea. So this is a very easy example. And if I execute this one, then we will see that we now get the same result from the query, or just execute the query first. If I execute this query, you will see this is like the sales over the time. And if I execute this thing, it will be the same outcome because I'm ingesting or exposing the thing to R and then it's returned. Of course, I can now then apply everything from my script. So I can do my machine learning model, whatever. So this is one of the use cases. And the other one would be, and now, I have Power BI not started, and I will not take the time to start it. Take some seconds. You can have an R script visual running in Power BI, and you can have R scripts and Python scripts, for that matter, also running in Power Query to transform your data. So it makes sense to learn the languages. That's the point of the 10 seconds I took here. So the good idea is then we don't move if you integrate in SQL Server, we don't move the data to R, export it or somehow, but we move the script to where the data already resides, which makes it easier for resource government, for security regions, and then you can operationalize your model. So when you load your data warehouse, as last step, you apply all the R scripts, you do the predictions, and everybody who has access to the tables can use the predicted values without having any knowledge about R or even know that there R was applied here. There are some pitfalls, we talked about that. So the conclusion is easy to learn, has its use cases, super fine integrated, and that's the end of this lunch talk. If there are no questions.
There is a question. I want to say that I really liked the session. I love that it was more or less all demos, and that you started on a level so even I could follow, because I haven't done any R programming. I looked at it when it was new, when SQL Server 2016 came out. Well, R wasn't new, but it was new for SQL. And then I played with some predictions, but I just basically downloaded code, loaded my data sets into it, and I didn't have a real use case for it. So, but I really like that you started on a much more basic level than I tried to begin with, because I didn't even understand the syntax when I tried to use the language, and that makes it a bit hard to work on.
But sometimes it's good enough if you find a script and you can squeeze it and it runs. Fine with that, yeah.
Yeah, maybe, but if I want to do something more, then I need to actually understand the language. So
yeah.
Thank you for that. There is a question from Wilfred, which is, what about the memory requirements? And I guess that goes for RStudio. What's
yes, if you load the data onto RStudio, of course, this has to fit into memory because the data frame is an object residing in your memory. And if it's not fitting in memory, then you cannot load the data frame, or you cannot add further things. So there is a restriction there. This would also be one use case where you think maybe not running this locally on your computer, but have it on SQL Server because there's more memory available there. I mean, this is also maybe the back thought of Microsoft, enabling running R things up there, because maybe then you need more processors, more memory, and you remember the license model of SQL Server is on your cores. So if you need more cores because you run the R scripts, the R integration is for free, R is for free, but of course there's the way how also Microsoft earns their money. If you need more cores, then they earn more money with the standard or enterprise license. Yeah.
And I guess when it comes to memory, if you run R on a server, let's say you run the ESP external script and you input a data frame, then that data frame has to fit inside the memory of the R engine.
Exactly.
So, and I'm pretty sure that's not going to be a part of whatever you set for max server memory. So reserve more memory for the operating system that you're used to. I'm guessing, but it would make sense because it's running as an external process. In fact, the R engine.
Yes, the Launchpad, which runs on the same server, but it's a separate process. So they separated it. So if there's something is really wrong, not SQL Server will die or SQL Server is influenced, but this is different process right there. And you have some control over the resource governance. So all the resource governor, you can decide how much memory you want to give this Launchpad service or certain users. Okay. Yeah, so this is part of that.
Okay, good.
So you have some control over that.
Yeah, and the reviews that I've read about how the implementation of the Launchpad service is that they gave it some thought before releasing it. So it actually works from the first time you install it, which is kind of different to some other features which have been shipped with SQL Server. Let's say column store indexes, they came out in SQL 2012 and no one could use them.
Yeah, really limited. Yeah, that's true. On the other hand, I don't like Microsoft for many things like naming. Sometimes they name things really, especially in Power BI, so it's really difficult for beginners to find out why, because the name doesn't make any sense for outsiders. But what they really do good, they really make very well, is the integration of things. Now think of that. You can run an R script on the server, just invoking a SQL script, invoking the data there, then it's mashing the things up and you store it back. I mean, it can't be easier be integrated. The same is true for the column store. If you think this is a different database, the column store is an index, like this is only marketing that's an index. It's not an index. It's a different database. It's a different way of storing and querying data. And they just made it an index and they just create index, column store index. But in reality, it's two different databases we have on the same machine and we can just query it and work with it. There they do a really, really good job.
Yeah, and it's they took a lot of that technology from Excel. So kind of when I try to explain it when I do SQL training, I say, well, if you've ever done aggregations in Excel, you know that it's pretty fast. So what they did was basically take an Excel sheet and attach it to your table and make sure SQL fills it every time you change your table. And that's not an easy thing to do.
No, it is not. No. I don't want to know how they made this happen. Yeah, because this is really
I saw on my first PASS Summit, I saw a level 500 session with Bob Ward and one of the developers from the SQL team, where they explained how they built the column store indexes. And I think it took me 10 minutes before I was completely lost. And they showed some C++ code or C code. And now it was mind-blowing. There are some smart guys working with this, or smart people, I should say.
Yeah.
I learned the other day that I should not say guys. For me, that means people, but it has a pronoun. So I'm going to unlearn. So.
The guys, the guys and gals, or the people,
Yeah. Anyway, I'm gonna try to do some actual paid work today as well. But thank you so much for coming to here. I don't see any more questions.
Yeah, there's a comment of Wilfried that he has a 500 gigabyte table, and if he wants to process this in R, he will need some additional memory, most probably, or be really restrictive what kind of data. I mean, you don't have to expose everything, only the columns you really need, only the rows you really need. Maybe you can limit it from that way, but yeah, think of that. And Grant.
And usually, at least that's my, I worked for Statistics Sweden for a few years, the Census Bureau in Sweden. And when we gave data to the number crunchers, the statistics people, they used another programming language, but very similar to R. They didn't very often want the raw data. They wanted it pre-aggregated to a certain level of detail most of the time. So I mean, that's the thing too. If you're going to predict sales, you don't need to put in every order line into the prediction. So, you just need if you need it by the hour, by the minute, or by the day, just aggregate it on that level of detail.
Yeah. And for all the products, maybe, and then you have different product categories, maybe where also do some predictions. So you have like five categories and one overall and one per categories, and it will be less data, of course.
Yeah. I think I need to do some playing around again and give it another shot. And I think installing RStudio, because I also, when I did it, I tried to do it with, it's kind of, Management Studio is not the perfect tool for developing external scripts, because it's a string and it doesn't give much. Is there IntelliSense and stuff like that in RStudio?
That's a good question. Do we have IntelliSense there? So, that's the red one, and then can't remember. The execute is no, there's no. Yeah. There's intelligence there.
Okay, good.
And then you can even get this. And of course, if you press F1, then it will execute the help function. They get also more details, description about what's happening
cool. Yeah, I think that's where I will go.
Mm-hmm. And what's also a good idea, if you do this in Power BI, this is also like, not very helpful, the editor there, but in Power BI, you have this arrow pointing to the top right corner. If you press there, then Power BI will export the script, load RStudio, having the whole script there and adding 3 lines up there, 2 comments, and 1 line is a load CSV. So they're exporting whatever you're currently using in the visual as a data frame, as a table or whatever, exporting as a CSV file, adding this line there, so you can actually work in RStudio with the data you just had in Power BI, make your query run, the script or whatever, and then copy paste the query. And I think this is also a use case for many people because loading data in R is much more difficult than with Power Query and Power BI. So it would make sense that you connect to your data sources in Power BI, build up the columns, whatever you need. This is then aggregated, so it's not the raw data, so it's smaller. And then press this button, having everything in RStudio work on your R scripts. And when you're finished, either use the script on SQL Server or copy it back to Power BI. This is also a nice way of working with that.
Yeah, and for me, Power BI is a completely different animal as well. So I think I'll stick to Management Studio and RStudio and try to get something to work there. But very, very good presentation, Markus. Thank you so much for coming.
Thank you very much. The pleasure was on my side.
I hope there will be an in-person SQL Saturday in Vienna or Data Saturday or whatever it will be. Are you planning anything?
Not concrete. I have this in my mind. We didn't start with organizing it, but I assume it should be an in-person event again, because everybody should be vaccinated over the winter. Yeah, I think it makes sense too.
Then I know where I will be beginning of 2022. To see you there.
Yeah, very good, very good. I'm looking forward. To have you
Bye for now
in Austria. Thank you, everybody. Thank you, everybody. Have a nice day. Bye-bye.